Well, hey there, gang. This is Crash here from the Crashcast podcast, and I'm here with, well, as you can see, a new video. And this video is for, let's see, I'm going to try to demystify the MultiWii Flight Stabilization systems. And we're going to start off here with this video with, well, my favorite inexpensive flight stabilization system. This is from ReadyToFlyQuads.com, and it is the FLIP 1.5 MultiWii controller, and $15 plus a little more for the case. I think it's less than $20 for this whole thing in the protective case. Now, there's tons of information on the internet about MultiWii flight controllers. The problem is you're going to have a hard time finding one place that gives you everything you need to know about getting started with one of these. Everybody, it's been an evolving piece of hardware and firmware for the last, I want to say, about 3 years. So, if you're new to multi-rotors and looking to build your first quadcopter, your first tricopter, whatever, then trying to get this whole thing figured out is going to be quite difficult for you. Or it may be. So that's why we're here. We're going to demystify this a little bit. So I'm calling this FLIP 1.5 for dummies, not to call you guys dummies, but just to following the dummies method, I'm going to try to lay out everything you need to know in an easy to follow tutorial. So that's what we've got here. Now I'm going to switch camera views and try to show you some of the things that we need to have here, and we'll see how this goes. Okay, now in addition to your FLIP 1.5 board, you're going to have a few other things. Well, you're going to have your trusty transmitter. I've got it on my JR 9303. You're going to need to have a receiver for your transmitter, and we got that. You're going to have motors and speed controllers, and I've got just a sample for the video's sake. I've got a sample motor and speed controller. Now, if you've got, let's say you're building a quadcopter and you want to, we're going to have to go through a calibration process. We'll talk more about that a little bit later. But in your calibration process, you're going to have to specify, you're going to have to tell these speed controllers what range of travel they're going to recognize from the lowest setting to the highest setting, the calibration process. And from, again, ReadyToFlyQuads, we've got this nice little adapter. It's basically a 4-into-1 that allows us to, we can calibrate 4 speed controllers all at once. So that might be an option that you want to get. You're going to need, here's an important thing. This is my wire kit that came with my FLIP 1.5. And basically that's going to allow us to hook up our receiver to our flight controller. So we're going to be needing that. You're going to need your USB cable, because even though ReadyToFlyQuads is going to allow you the opportunity to they will pre-flash your board for you if you're flying, let's say, a quad in the X configuration or a quad in the plus configuration, a tricopter, a hexacopter, whatever you're looking for. Paul Whitespy over at ReadyToFlyQuads is going to pre-flash that board based upon what you suggested. Nonetheless, you're still going to need to communicate with this board with your computer. So you're going to need the USB cable. And I don't know what size it is. It's very small. I would say get it from ReadyToFlyQuads. It's only $1. Good luck finding a USB cable that cheap at your local Radio Shack or Best Buy. Let's see, one more thing here. Well, a couple more things. We're going to need a battery. Oh, there's my battery. Just a little 3S 1300. And I like to supply voltage to my receiver when I bind it. You can do a couple of different things. You can hook up your receiver to your speed controller, but then you have to have your motor wires soldered and everything. When I power up the speed controller to bind it, I've got just a little inexpensive, like $6 or $7 from Heads Up RC is where I got it. I think ReadyToFlyQuads has them also. But it's just a little BEC, a little switch mode BEC that allows me to get the power from the battery down to the right voltage through the BEC to power up the receiver to bind it. Okay, so that's the things that we're going to need. Additionally, we're going to need some software, and we'll go to a screen capture so you can see what kind of applications you need to pull down from the web. Okay, as I mentioned earlier, we need to download some software. So we're going to open up our browser, and there we go. And we're going to need to unplug that. We're going to go to ReadyToFlyQuads.com. We're going to go to Flight Controllers, and we're going to find our FLIP MWC Flight Controller 1.5. And when you order this board, you have the ability of choosing a few things here. First of all, you can get the protective case, like I've noted. You saw the picture of mine before. I recommend that. It protects that board really good in a crash. And you can also choose the firmware that you want to use. Now, what I'm going to do, just pick any one of these. That's fine. Quad X is what I fly. That's the OPQ. 2 motors in the front, 2 motors in the rear. And we're going to assume for this exercise that that's what you've done. Now, I do notice that Paul is flashing these boards with firmware 2.3. So again, for this exercise, I'm going to take you through and show you the whole thing. So let's assume that you've purchased one of these, Quad X or Tricopter or whatever. You've had a firmware, but it's the 2.3. I personally haven't used the 2.3 software or firmware yet, but you still have the ability to get 2.2. 2.3 is fairly new, and I understand it's got some more complex features to it. So we're just going to go to 2.2 for this exercise again. So we're going to click on this, and this is going to take us to Ready to Fly Quads Dropbox page for MultiWii 2.2 on the Flip 1.5. And there's some things that you're going to want to download. First of all, download the Arduino 1.0.3 package, and that's how you get firmware onto the Flip 1.5. So you're going to need that. Let's go through here. There's a lot of selections here, but for this exercise, we're going to come down here and we're going to grab, let's see here, just the MultiWii Flip package. This is the firmware that we flash to the board using the Arduino IDE, the first link that I showed you. We're going to grab MultiWii config.zip, grab that, and that is our utility for changing some of the settings on the board. And then if you need drivers, and you'll know as we go through this exercise, if you need drivers, you'll grab this package. And then finally, the WinGUI 2.2, you may elect to use this. This takes the place of MultiWii config. Some people like it better. Personally, I just use MultiWii config. Anyway, download those to your desktop. And I've already unzipped some of these, but there's what I have. Now, the first thing you'll want to do is let's install the Arduino software. And you can extract this to your desktop. I've already done this. This is a fairly lengthy extract process. But what you'll do, and let's pull this up here. We're going to go to my computer, and at the root of your C drive is where you'll place that Arduino 103 folder. And this is what it's going to look like. Just these files and folders. This Arduino EXE, you may want to right click that and then send that to your desktop so that you have it in a handy spot. I have actually already done that. There it is. So that's how you install that. The next thing we've got is our MultiWii Flip. Now this is our folder that contains our sketch data. Now what a sketch is Arduino, when you program in, I guess it's the C+ programming language, when you create a program, it's called a sketch in Arduino speak, if you will. And this is everything you need for a MultiWii quadcopter. And we're just going to take this folder. We can leave it on the desktop, that's fine, but what I like to do, we'll go back here. What I like to do is put it in the Arduino folder, and I just drag this guy right over here, just like that. So now it's in here in my Arduino folder at the root C. Okay, and let's see what else we've got to do. Here's our driver package that you may need, and I'll show you if you're going to need that or not in a minute. And then here's our MultiWii config, and you can just leave this folder sitting on your desktop, We'll get to that in a moment. And then here is WinGUI. And I may open that up and show you a little bit about it, but I don't use it, so it's there if you need it. Well, let's see. The first thing we should do, since we got our board from Paul and we specified, even though we specified version 2.3 and we're not going to use version 2.3 of the firmware, it'll still be a firmware on the board that will allow us to find out if our computer is going to communicate with this board. So take your USB cable and plug that in to the board and then into your computer. And you'll hear your computer recognize it. And on the board there'll be some lights. There's a steady green, a steady red, and then there's a flashing blue, which the flashing blue just says, hey, I'm loading the firmware that's on it. So that's good. We've got a board with firmware. Now the next thing we can do to make sure that we're able to see this, you can go to your control panel. And let's see, we're going to go to hardware and sound. Let's try that. I don't remember. And we're going to go to device manager. That's what I'm looking for. And I don't see it here. I'm kind of hurrying. Let's just close that. Go to your Windows button, like you'd hit start, and go to right click on my computer or computer. And then that'll bring up this. I'm in Windows 7, by the way, a 64-bit Windows 7 machine. We can come up here to Device Manager, and we're loading all of our stuff here. Now what I see when I go to Ports and Pins, I see that we have the Silicon Labs CP210X USB to UART bridge, and it's assigned, my computer has assigned COM3 to this. So I know that my computer is working just fine with this device. It's reading the board, everything is working dandy. Now, if you're getting an error, well, you might want to right-click and update the driver software. And the drivers, again, we downloaded. There's our USB drivers. And you can use those to get it to where your board is talking to your computer. Once you know that that's working, then you might want to go ahead and test the board. But this, for right now, we're just going to go with this. We've got a board. It came in flashed. And at this point, we've tested it. We know that our computer is talking through COM3 to the board, and we're ready to do the flash. Like I said, we got it at a version 2.3 firmware. For this exercise, we're going to change it to a 2.2 so I can show you the whole routine of flashing the board with a sketch. The sketch is the firmware in Arduino speak, I guess. And then we'll start setting things up. So we'll get into that in the next video because we're running a little long here. Okay, well now we're going to write a fresh version 2.2 firmware to our board. Okay, so we're going to click on our arduino.exe shortcut, double click that. It's going to give you this. I'm going to check that off, and we're going to run it. Okay, now we need to load our sketch. Okay, so we can say File, Open, and if we go to this opens right in the Arduino folder. So if we click on our MultiWii Flip that we downloaded, and we're going to look for this .ini file. That's our source code. So we're going to click that and open it. And I'll just briefly show you what we've got going on here. This is our sketch. This is everything it takes for MultiWii Flip or MultiWii version 2.2. And we can tell it's 2.2 because, well, there it is. Now we're going to go over here to our config.h. I'm going to show you something about this real quick. This is where we're going to set up the board. Now, because we downloaded this from ReadyToFlyQuads in the Flip 1.5, the version of the firmware that we downloaded should have everything we need. And look at here, it's already defined as a Quad X. Now, how do I know that? The type of multicopter, we have all of these items that are kind of grayed out, except we see Quad X is made bold. Now, if we wanted to change this to something else, we could do that just simply by putting 2 forward slashes. You'll see I drop that in, and now that's grayed out as well. Let's say I wanted to make this a try, then I could just take away these two forward slashes, and we are now defining this board as a tricopter. And it's just that simple, right? Incidentally, I want to address something here. If you have a tricopter and servos, depending on how you mount a servo to your tail boom to set up your yaw tilt rotor mechanism, sometimes you may find when you're trying to fly this thing that it breaks off the ground, like you're trying to pop off the ground into a hover, and the very first thing it wants to do is set into this uncontrollable, unstoppable spin. Well, if you have that happen, you can come down here. I'm going to see if I can find it right fast, but you can come down here and define the servo direction. And there we go. For a tricopter, you have instructions here for yaw. And if you should ever get into a situation where, okay, everything is good, everything is set up, I know everything is correct, but the thing breaks the ground and it just goes to spinning. Well, that means that it's I'm going to put it, the servo is based upon your mechanical setup. The servo is wanting to tilt the wrong direction, and reversing that in the radio is not going to help you. So if you had that happen, our default here on this package of the sketch here is defaulting to a positive integer 1. You just see it's a number 1, define yaw direction. Well, we could come over here. If that happened to you with a tricopter, you could come over here, insert a couple of forward slashes to gray that out, and then on the next entry, take those forward slashes away, and now you have your yaw direction set to a negative integer. And that is in as much as saying that, hey, I have changed the servo direction. It's just that easy. Well, I'm going to put this back right fast because we're going to flip the, or we're going to put Quad X firmware on it. Again, this is version 2.2. I'll scroll back up. We're going to comment this out with 2 forward slashes. We're going to come back to Quad X. Set that, and at this point, we've got a factory Quad X. Quad X is 2 motors front, 2 motors rear. Okay, and that it's just that simple. You don't have to know how to be a programmer. You just have to know how to set the stuff up. And if we had made changes, you might want to save this as a brand new sketch. And just for grins, I'll show you. I'm just going to come over here and say save as. And in Arduino, I'm just going to call this multi-flip _ crash. And I'll save it there. And now we have that. Okay, now let's flash this to our firmware. And flash our firmware to our board. I'm going to plug this board in again. And again, this one came in as a Quad X, but 2.3. Now, unfortunately, once you've flashed a version of firmware to your flip board, you can't read what that board is flashed at. You can kind of through a utility, but it's difficult to do. I mean, we compile the sketch from ASCII data that you see on the screen to binary language, and it's just difficult to decompile that. So it's best just to come up with a new sketch and flash the board again. So this is what we're going to do here. We're going to flash this board. And the best way to do this is we're going to go, first of all, we're going to go to Tools, and we're going to go to the serial port. Now you can see I've got a checkbox by COM3, and I already know from our earlier video, we already know that my computer is communicating to my board through COM port 3. So that's checked, that's good. The second thing is we're going to go over here to the board, and you'll see there's all kinds of different Arduino type boards. The one that we want to select, and mine is, I've run this program before, so mine's defaulting to it, but you want to select for a Flip 1.5 controller, you want to select Arduino Pro or Pro Mini, 5 volt, 16 megahertz with ATmega 328. If you don't select this and you don't have the COM port selected properly, then you're probably going to fail in compiling and uploading this sketch or firmware to your board. So I've got it correct here, so we're ready to go. Now I want you to watch right down here what's going to happen. When I come up here to the top and I hit my upload button, Then down here, we are compiling the sketch. It's putting it in binary, and it's uploading. I've got a little status there. And if I don't have any errors, then it will tell us done uploading. There it goes, right there. So now, at this point, I have updated the firmware. We went from, you remember for this exercise, we were Quad X 2.3, and now we're at MultiWii Quad X 2.2. And anyway, it's just that simple. Now at this point, we can close this and close this, and now we're ready to check out what we did. If you use the MultiWii config right here, I'm just going to open this up. This was on our desktop still. And MultiWii config, if we open this folder up, we've got several different executables here, depending on what kind of computer you're using. Linux 32 means a 32-bit Linux machine. Same 64, self-explanatory here. I'm running a Windows 64-bit machine, but I have noticed I have never been able to get the Windows 64 executable for the MultiWii config utility. I've never been able to get that to run on any of my 64-bit machines. But don't worry, we're just going to use the Windows 32. And there is our executable. So we're going to double click that. I'll close this window. And this is the MultiWii config utility. You'll see on this left-hand side, we've got COM3. Now I know that my board is hooked up and talking to the computer, and MultiWii config is seeing it. And if I just click that right there beside COM3, you'll see that everything went green. So now I can start communicating with the board. Well, to start communicating, follow my cursor. I'm going to hit Start. Now I can see here, these are the values that we can change in our firmware, in our flight stabilization board. This is all of our PID settings, and I don't recommend you mess around with those unless you know what you're doing. I still don't fully understand PID. But anyway, there's some rates and expo levels and so forth. And we can see these lines going here. And these are status indicators of what the sensors are feeding back to the from the board to our computer. And we've got lines here for roll, pitch, and yaw for our 3-axis gyro, and then for our accelerometer. And that's what these lines are showing. If you come over here, you'll see our 3D rendering of our Quadcopter X. As I pick up this board, you'll notice that it's going to move. And we're getting some sensor feedback, and that's what you want. And if I tilt the board, I'm looking at the board with the arrow to the front, away from me. If I tilt it to the left, we can see that this is, our rendering is showing that that's what it's doing. To the right, nose up, nose down. And of course we've got an incline gauge here that, sees it if you were a pilot sitting in it, sitting in the aircraft. But now we know that everything is working. And we can see the changes and all that we might want to make. And I can tell you with the flip board, Paul has gone to, efforts to come up with PID settings that will pretty much handle, pretty much make you a good flying multi-rotor right out of the box. And these are good settings. Like I say, I wouldn't fool with changing your PID settings on anything unless you know what you're doing or you have somebody helping you. If you do start monkeying around with them and trying different things, by all means, get yourself a screen capture of the stock configuration, the stock settings. You're going to want to have that. And if you needed to make a change, we could just put our cursor on there and left click and move it. And then once we release the button, that's the value we have. And I'm going to take it right back to 3.3. Okay, and that's how we would make changes. And once I've got new settings in, then all I have to do is come over here and click Write. And that's going to write whatever changes in this box that I've made. It's going to write it. Now, before we can go into these things here and talk about all this, we have to have a bound receiver hooked up to our board with a power supply. So we'll get into that shortly. I do want to explain that when you get a Flip 1.5 board right out of the box, it's been flashed and all, You know, a lot of people think that, okay, it's ready to go, but it's kind of not. It is ready to go. If I hook this board right up to my quadcopter and went out, took it to the front yard and popped it into a hover, it's going to fly. However, I'm only going to be able to use the gyro as the sensor for flight stabilization. And that's good. That keeps it from trying to crash itself, we'll say. But the accelerometer is where the magic happens for stability. And there are a couple of different modes that we can assign for accelerometer. But the thing is the accelerometer is assigned by a switch on your radio. And Paul will not have any way of knowing when he flashes a standardized firmware. He won't have any way of knowing, you know, what switch position your radio needs to be in or will be in. Is it a low state or a high state on the ppm stream? These are things that he would have to know up front, and he's just not set up for that. Anyway, we're going to assign those values. So this gives you basically a brief rundown. We flashed the board with our Arduino sketch. We've got the right firmware on it, and we've since loaded up the MultiWii config utility so that we can start the board and see the values and see that it's working. Now when we're ready to stop the board, we're just going to come up here just like where we started it. Well, we're going to hit stop. And that cancels the data transfer from the sensors to our PC. And then we're going to, before we do anything else, before we unplug it or power down this program, the next thing we need to do is close the COM port. So hit close COM. Everything is all red here. Now it's safe to close this and to unplug our board. Okay, real quick, I'm going to show you the WinGUI, which is the alternative to the MultiWii config. Like I said, sometimes people don't like MultiWii config and they prefer the WinGUI. So we've got that folder here. We downloaded that, and I'll show you what it looks like. We double click that, and then down here we've got our executable, MultiWii WinGUI.exe. So I'm just going to double click that. And here is what it looks like. Now we've got our COM port. I wonder if I have any other ones. Nope, just COM port. And I'm just using the default speed. And if I click connect, and of course my board is plugged in, well, now I can see all of the data that we have associated with our board. And here's our control settings. This is how we can use our switch assignments to communicate what mode we want to be in, if we want a remote arm or an angle mode or horizon mode based upon our accelerometers. And then we've got our real-time data, and this is showing our accelerometers and our gyro. And if I pick this up, you can see our incline is changing just as we would expect to see. So you may opt to use this one. Again, for this exercise, I'm most comfortable with MultiWii config, so I won't be using this. So when we're ready to stop this, we will just go to disconnect. And once it's disconnected, we can close it and unplug our board. So I wanted to show you what that was all about. Okay, gang, with our FLIP 1.5 board flashed with the version of firmware that we intend to use, in this case, version 2.2 of the firmware, with our Quad X configuration, the next thing we need to do is hook it up to our receiver. Now, first off, we need to bind our receiver. And I've got just a Spectrum receiver here, and you'll want to follow your instructions in your manual for the transmitter system that you're using, the radio system, for the correct binding. Now, we need to get power to this so that we can bind it, and there's a couple of ways of doing this. If you have an old flight pack, this is just a 4.8 volt flight pack, you can use that. Just plug it into your throttle. This one's dead. I don't have any good flight packs since I don't fly nitro anymore. But you'd plug that into the throttle so that you could plug your bind plug into battery. Again, refer to your own manufacturer's instructions on this if you don't already know how to bind a receiver. You could also powered up with a speed controller hooked up to a motor. You want to be sure the motor is hooked up, because if you leave these motor wires loose and not hooked up to a motor and they short out while you're doing the bind process using your speed controller's BEC to provide power to the receiver, well, then you're probably going to be in trouble there. You're probably going to short out that receiver or that speed controller. What I like to do, I've talked about it earlier, but I use to power up my receiver, I've just got an inexpensive switch mode BEC that I'm going to plug in. I don't want to plug it into battery, because on Spectrum that's also the where the bind plug goes. So I'm just going to plug it into throttle as such, and then I can power it up with a standard lipo battery. And again, our BEC is going to reduce down to about 5 volts power of the 3S lipo to the receiver. So bind your receiver up, and then we'll get ready for the next step. Okay, our receiver is now bound up. Now I want to point you toward the instructions that are going to come with your Flip 1.5, and namely, we're going to set our transmitter up. Now the things, again, if you don't know how to do this, you'll want to refer to the information in your instruction manual with your radio. But the first thing we want to do is we want to put our airplane or our radio in airplane mode. We don't need helicopter mode or anything else. We want airplane mode. My JR gives me options of different modes, helicopter or airplane or even glider. We want it in airplane mode. The second thing you want to do is you want to set your throttle in its position. Like here, I've got throttle in low, and I've got the trim taken all the way down to 0 on this radio. And now finally, you want to set your travel. You want to go into your programming for your travel adjust, and you want the elevator, the aileron, and the rudder to be set to full travel throw of plus and minus 130%. That's going to be very important for this operation. So again, 100% travel adjust on your throttle with your trim at its lowest position, and then your other 3 channels, aileron, elevator, and rudder, set those to plus and minus 130%. Now when you have that done, your receiver's bound up and your radio is set, the next thing to do is start hooking things up. Now I have here my Flip 1.5, and I have attached it to my receiver as such. You can see you may be able to see the Flip 1.5 has lights on it. I've got a green and a red light because I'm already plugged into the computer. I've taken my servo wires and attached them to the receiver. And a trick here, if you only get 3 wires, well, that's fine. What we do is we insert the throttle just like a regular servo, where signal is on top, positive current is in the middle, and then at the bottom of the board, opposite the print, is going to be our ground. Now our next wire, our next servo extension, we can actually just span it across the top wires, and that's going to give us, I've got the light color, which is normally the signal. This is going to be kind of hard to see, but I've got the signal on aileron, I've got the red positive on elevator, and then the rudder or yaw is our ground wire, and that's just spanning across the top pins. Again, I know that's not going to be easy to see on this camera. And then finally, the third wire, I've got it plugged in, again, just like a normal servo, where I've plugged in top is signal, and then red, and then black going down on the bottom, and that's plugged into auxiliary 1, which is our 5th channel for me. Okay, and I've got my power supply ready to hook up to my receiver, and I'm going to turn my radio on, and I'm going to plug this into my battery. And now I've got my receiver powered up. We may be able to see I've got a little light there shining. Receiver's powered up. The Flip is powered up through the 5-volt USB rail on the computer. And now everything is ready to move on to the next step, where we're actually going to set, we're going to fine-tune all of our throws and such on our Flip 1.5 using the MultiWii config utility. Okay, with the receiver powered up, hooked to the flip board, transmitter on, we're ready to go to our MultiWii config. And remember, we go into, for a Windows machine, we're going to go into Windows 32, and we're going to launch the MultiWii config executable. And we'll bring that up where you guys can see it well. Okay, now if I open up COM3 by clicking it, it turned green, we're good, and I start the board. There's going to be some things that we're going to notice here. You may recall that any settings that we're going to make here, we're going to make, and then we're going to write to the board. Okay, now let's look over here mainly. This is what we're concerned about at this point for this next thing. Now, if I take, and I've got my throttle at its lowest position, you'll see that we are on this side of the scale. As I advance the throttle, you'll see that that's moving up, right? Okay, well, we're going to fine tune that. I personally like to see a range of about, on the high side, about 2020 pulses per minute, and on the low side, I like to see it at about 980. In fact, we're going to do that on all of these. So what we're going to do is we're going to go into our radio program, and we're going to change the travel adjustment. So I'll start first on throttle, and I apologize, you can't see it on the radio, but if you're not using a JR9303, it's probably not going to make a lot of difference to you. So I'm at 100% on the low side, and I'm going to start bringing that up, and there I'm at about 981, and that on my radio is 107%. Now I'm going to move my throttle stick up, and we can see the scale increase, and now I'm going to change the high side. I'm going to bring that up until I hit about 2020. And 2022, that's perfectly fine. And that corresponds to 137% on my JR. So with this point, we've got a high side 2022, and that's pulses per minute. And on the low side, about 980. Okay. Now, again, from the stick in the lowest position, we've got our low PPM. And at the highest, as we move the stick up, the bar moves to the right for our approximately 2020. Now, let's go over to the next channel. Pitch is also elevator. So if I move that stick all the way down, I'm at about 990. So I can go in to my travel adjust for elevator. And as I move the stick down, I'm going to bring it up from 130 to that's pretty good, about 976. That's 132%. Now we're going to move it to the top side. As we move the stick forward, we should see our graph go up. And in this case, we're at 1989. So I'm going to fine tune that. I'm just changing my travel adjust. And we're going to take it to about 2020. And we're at 2022. That's fine. So again, low stick, full up elevators, what it would be in airplane mode, we're at 982. Center, we're at about 1493. And then to the top side with a stick full up, which would be full down elevator or full forward pitch, then we're at about 2020-ish. Okay, now something that we're going to notice here right away, I've got my throttle stick in the middle. There's no sense in arming my board. You'll learn more about that. But I'm going to move my stick, my rudder stick, to the left. And you'll see it went, our stream went up on yaw to 2026. Well, I happen to know that this thing, these bars should move in correspondence to your sticks on the horizontal plane. So this needs to be reversed. So I'm going to back out in my list, go to my servo reversing, and I'm going to go to rudder, and I'm going to reverse that. And we'll go back to travel adjust. Okay, now when I'm at full left rudder, as you see. Now we're at 986. That's, well, 982. That looks pretty good. That's where I want it. Now, as I move my rudder to the right, all the way over to the right, I'm at 2043. So I'm just going to back down on that one just a little bit. And we're going to try to take it to about 2020. That's pretty good. And I'll release it. So again, rudder full left should go low to about 980. Full right should go high ppm to about 2020. Okay, and now we're going to go to the aileron, or the roll, which is this one right here. I'm going to move my stick full left, and it should go down, and it's not. It's going up, so I need to reverse. On JR and Spectrum, you need to reverse those channels. So we're going to go back to servo reversing in my radio. We'll go over to aileron, we'll reverse that, and we'll try it now. So aileron full left, now it's going down. We're at about 990. And we're going to adjust that. Full left, I'm going to bring it down to about 980. I'm going the wrong way. 983 is close enough. Full right on the aileron or roll is at 2023. That's pretty good. We're going to leave that alone. Okay, so we know on JR and Spectrum we need to reverse aileron and rudder. And now we have our full travel here. We can see also down here on the motors, this is what's being sent right now to the motors in the state that the board's in. It's a little unlevel, so it's trying to fight that being unlevel. It's okay. But on the high side throttle, we've got at least 2020 on the high side, on the low side about 980. And rudder, low side left, high side right, again about the same range. Pull the elevator stick completely back for up elevator, and which is pitch. We're at 981. We'll move full down elevator, full forward, and that takes us to about 2021. And then finally our aileron or roll, full left, we go down to 983, and full right we go to about 2025. That's going to be just fine. So our radio now is set up. Okay, now with that, we're ready to calibrate servos, but we're also, or I say calibrate servos, calibrate speed controllers. But there's another thing we're going to do here. We are going to set this thing up. Let's see, I've had a few things. I've used this stuff on a few different things. I want to make sure we're not. Okay. On your gear switch or your fifth channel, I have a 2-position switch naturally. And I want you to notice aux 1 is your fifth channel. And when I have it toward me, it's low. When I have it away from me, it's high. Now we don't have to put in rates on that or just the throw values on that. We can just observe. This is away from me is high, towards me is low. Now, if I want to work with using an accelerometer to augment my flight, I like to use angle mode, and I'll give you a brief description a little bit later, the difference between angle and horizontal. But I use angle. And I've currently, you see how this is green on arm? Well, that's because I actually have the board armed. There, I'm going to unarm it, and I'll tell you about that too. You can actually use another channel, a 6th channel if you desire, to arm it. But we're not going to go into that right now. Okay, again, I like to have, when the stick, and this is purely up to you, but let's say if I like the stick fully away from me on my 5th channel, again, aux 1, that's a high side value showing 1906. I like that to be acrobatic mode or just gyros. But now if I want to bring in the accelerometers, I would like to have that switch to where when I pull it toward me, then the accelerometers are on. The reason I like to do that is for my big old hands, if I'm flying around in acrobatic mode, and then I get in trouble and I want those accelerometers to help tame my flight, it's easy for me to take my big hands and go and kick that switch back on this particular radio. And, depending on your switch layout, you may want to, change that however you want. So with the switch toward me, in this case, or in a low ppm state, that's when I want to run accelerometer. So I'm going to come over here. This is aux1 channel. I could also use aux2, channel 6, channel 7, or channel 8. If I were using as much as an 8-channel receiver. I'm only using a 6-channel receiver. So I'm going to come over here to angle, and I'm going to tell it it's a 2-position switch, so I only have a low state or a high state. So I'm going to say that on a low state, the stick toward me, that's when I would like this to go into angle mode. So if you just click on that little box, sometimes it's a little cantankerous, but I clicked on it and you'll see now I've got a block in there that's filled in that says when channel 5, aux1, is in a low state, angle mode will come on. Now I'm going to go over down here now and I'm going to write that to my board. And you'll see this turned green because I'm in a low state. If I move it away from me and put that 5th channel in a high ppm state, it turns off. Okay? Just like that. And with this, we have our board completely set up. There's one other thing that you might want to do with your flight controller. Now, right now, my flight controller is away from a quad. It's not mounted or anything. But once I have everything all mounted and ready to go, I could calibrate my accelerometer. And that's where I would put the quad in a nice flat area, completely flat, or as flat as I can get it. Don't touch it. And then I could actually say, calibrate ACC. And that has calibrated the accelerometer now. And that gives us a nice state. Now, a standard practice that I use, I always calibrate before I fly, and I'll show that that process to you later with stick movements. Anyway, at this point, our flight controller system, our radio, everything is all set up and ready for us to go. Ready to go for us. So I'm going to unhook the power to my receiver. I'm going to turn off my transmitter. And I'm going to come over here and stop reading the board. Stop. I'm going to close my comm. And now I can turn everything off and unplug it. So our next step is going to be to calibrate our speed controllers. Okay, you can probably see here I have unhooked all of my wires from my receiver that were going to my FLIP 1.5. And that's because when we calibrate our electronic speed controllers, we don't want to do that through the board. We want to actually do that because that could be dangerous. We want to do it just separate. So all I've done is I've taken my bound receiver and I have plugged in this speed controller to my throttle channel on the receiver. So with that, if I turn on my transmitter, and I'm going to take that stick and go all the way high, so it's full throttle, and I'm going to plug in my battery to the speed controller, and this one chimes kind of quiet, but it chimed. Now if I take my stick and I go all the way down, now it is chimed again, and it tells me now that I have the full range on that. So I can go full throttle and all the way down until off. Okay, so now that speed controller is now calibrated. That speed controller now recognizes the full ppm stream, and that's what's going to happen when you first power up a speed controller. It's going to be looking for, hey, what's my high point? So by taking it to full throttle and plugging it in, it's going to recognize, hey, that's the high point. And then I take it all the way down to the low side, and then it'll chime again and it'll store in, excuse me, that's the low point. So that's what we've done here. So I can unplug that and I can repeat the process for the other 3 speed controllers for this quadcopter. Now, if you had a power distribution harness and you had all 4 speed controllers plugged into one common power supply, and then you could do that. You could plug in the battery to that common power supply, and then you could actually run a harness like this. This is a 4-into-1, where I could actually plug in all 4 speed controllers on the signal side to the harness, and then I could plug that one in to the throttle channel of my receiver, and I would have all 4 speed controllers recognize that same high state, low state for the full range of ppm that is going to be given out by this radio system. So that is an important step, and certainly one that you need to do. Now at this point, I've got that all unplugged. At this point, we're ready to continue with our quadcopter build. We can put all of our components in place, and I will show you a little bit about stick commands. At this point, you're going to be ready to go, ready to start playing with your new toy. Okay, what you see here is one of my OPQ, my one-piece quads. And I want to show you how everything is hooked up. I've got my speed controllers and motors mounted. Everything's plugged in. I've got my receiver over here, and I apologize if you can't see this well, but I've got my receiver running my wires to my flight controller, my FLIP 1.5, and then I've brought in all of the signal wires for my speed controllers to the output side of the FLIP 1.5, and this is the front this way. This is the rear. So if you look, there's an arrow on here pointing to the front. A couple of things. I've got all of the speed controllers running into a power distribution block so that when I plug in the battery, all 4 of them get power. And a couple of things that I would like to show you. The board, this case here, is actually printed out to where we see D3, D9, D10, D11. Or for our speed controllers for our quadcopter. And I wanted to tell you that at this point in your build, you're ready to test things. It's very important that all of your motors are spinning the correct direction. Okay, this speed controller, which is your front right, front left. I'm looking at this backwards on the camera, but I've got it set up. This is the top. So this guy right here, this ESC, is going to plug into D3, and our signal wire, which is yellow or white or tan, something like that, is going to go to the top of the board. The bottom is ground, the middle plug is power. So this guy here plugs into D3. This one plugs into D9. This one right here is D10. And then finally, this one here plugs into D11. And then if you've plugged all of those up correctly, you should be able to power your system up. One of the things that you need to know anytime you're flying one of these, before you power up, always radio on first. Okay? And with the quadcopter flat and level, not upside down. You don't want to have it upside down, because as the firmware boots up, it's going to take a reading off your gyros and your accelerometers, and it's going to establish a baseline. If you plug it in, get in the habit of plugging it in upside down like we do with some of the toy quads, then you're probably going to have problems. It's going to want to flip over. So anyway, at this point, what I'm going to do, transmitter's on, I'm going to plug it in. And we are hot now. Now I want to show you how we arm and disarm. And I'm going to try to spin my radio around here backwards so that you can see. But low throttle, and if I go down and to the right, we are armed. And that you can tell because, although you may not be able to see, we have a blue light on the board. So if I advance the throttle, motors are going to spin. Now to disarm, low throttle or throttle off, down, and this way. And our blue light went off of the board, and now when I move the throttle, nothing happens. So that's disarmed. So again, arm, down, to the right, we have power, down, to the left, disarms it, we have nothing. Okay, now at this point also, I'm going to go ahead and unplug this. This quad is actually flown, so I don't need to go through this on this one, but you want to make sure that your motors are spinning in the correct direction. Again, this is our front, and I'm going to pull up some props here to demonstrate, but this motor here, your top left, that needs to spin in this direction, if that makes sense to you. And the way I look at it is the prop is on the outside and it's coming around to the front middle, and my prop is the prop that I've chosen is going to create lift. If I put a different prop on and it's spun that way, well then the leading edge of the prop is going to push it to the ground. It's not going to create lift. So you want to go through and make sure that your motors are turning in the correct direction. This one will be turning clockwise. This one will turn counterclockwise. This one right here will turn counterclockwise. And this one will turn clockwise. So at that point, if your motors are not turning the correct direction with no power to the system, you can pull out the bullets and swap any two of the three connections. If you swap any two, that will make a motor turning in the incorrect direction turn in the correct direction. That's just brushless motors 101. Okay, so at this point we are just about done with this, and I think the next thing, we're going to put props on it, and then I want to show you, give you a couple of explanations and some resources to try out. So the next time we come back, you'll be looking at my screen top again. Okay, gang, at this point you should have your quadcopter about ready to fly. There are a few more things that I'd like to show you. First of all, let's talk about some resources. Pretty much everything that I've gone over here can be found online at ReadyToFlyQuads.com. If you come over here to this tab here, the RTF Wiki, and you check this out, pretty much everything that I've discussed, and then a whole lot more if you were using a different board or barometric pressure sensors or GPS or things like that, you would be able to find, information upon those, I guess, more complex setups right here at this Ready to Fly wiki. But everything that I've discussed is, you can find it all here if you want to read more about it. Now, if I scroll down here to something that I wanted to show you, this is our quick start guide. Remember how I told you how to arm the motors and disarm the motors? Well, here it is right here. I'd also suggested to you that before you fly, first off, you want to be sure you plug your battery in with the quadcopter flat and level on the ground. Don't flip it over upside down. That's just a good practice. But also for, let's see here, scrolling down, for our different calibrations. Again, this is in writing. This is what we need to do to arm the board, and then what we need to do to disarm. Well, when you first power up your quad on flat and level ground, you can very easily calibrate from a fresh start, calibrate your gyro and your accelerometers. And there's an instructional on right here on how to do that. And basically, with a quadcopter disarmed, place the quadcopter perfectly level. It must be completely static, nothing bumping it or anything. Make sure all your transmitter trims are in the middle positions, neutral, except, your throttle. We had throttle off, and we had the trim pulled all the way back. Let's see here. But with that, if you put your throttle completely in its lowest position and hold left rudder, you remember that's disarm, and then bring the elevator stick full back for just a second. And when you do that, you're going to see the LED blink real quick for a few seconds, and then when it quits, and you don't have to hold that, you just hold it in disarm mode with full up elevator, or full aft cyclic is what it's called. the elevator stick completely toward you. Hold it there for just a second until you see the light start blinking on the board, and then you can release it. And that's going to calibrate your gyro to a flat and level position. And the same thing holds true for the accelerometer, except with the accelerometer, you're going to, with the quad disarmed, you're going to go to full throttle. And this is all discussed right here. You'll go to full throttle with full left rudder, and then pull that elevator stick back to you for a second, and then you'll see the green LED blinking fast, and then it's going to go out. And what that means is that now when you've got the accelerometer completely calibrated and you're ready for your first flight. So those are some things that are just right here on the Ready to Fly wiki that I wanted to cover. Also, there's a nice explanation just after that on flight modes. Remember how I told you to set your quad up in angle mode on that 5th channel? Well, here's a nice description of what that's doing for you. Angle mode is self-leveling. It activates the accelerometer. This is a great environment to learn your hovering, to fly in when you're flying FPV for your first flights. You will not be able to flip your quad in that mode. In other words, I think it's a 30-degree limit. No matter how hard you bang your sticks, your pitch and roll and your yaw, no matter how hard you bang those, you're not going to be in a position where it's going to flip over on you. It's going to hold, I think the maximum travel from straight and level, I think the maximum it's going to go is about 30 degrees. Now, the horizon mode is a little more for, we'll say, a more experienced pilot, because it's going to, when your pitch and roll and yaw are in the center, in neutral positions, then it's going to act like it's in angle mode. In other words, it's going to be very stable. It's going to hold itself in position really nice. But then again, when you put in full pitch or full roll or full yaw, it's going to react to that. So if you get in trouble trying to do some aerobatic maneuvers, if you get in trouble, you just return the sticks to the center positions, and it's going to straighten itself out. It's going to find level and try to settle into a hover again. So that's the reason I had you put it in angle mode if you're a noob. Nothing wrong with that. And then later down the line, you may graduate up to horizon mode. Okay, and then finally, there was one more thing that I wanted to share with you. I'm going to close this, and we're going to open up, there we go, open up our configuration utility, our MultiWii config. And I'm currently reading the board that we've been working on. And I wanted to talk to you about a few things here. Again, we're using angle mode to start out with. Let's see here. Okay. Again, we don't want to play with our PID settings unless you just happen to know what they are, or you get some direction from somebody who knows what they are. The factory PID settings for pitch, roll, and yaw have worked for every single multi-rotor that I've put together, and I haven't had to tweak any of them. Now, there are some other tweaks that you might want to consider. I don't fool with any of this stuff down here, but let's say you fly your quadcopter or your multi-rotor for the first couple of times out, and you're noticing, wow, this thing is breaking ground way before mid-stick. We like on these things, we like to sustain a nice stable hover at mid-stick on the throttle. And if you're using like Paul's red motors at ReadyToFlyQuads or bigger props, and you're finding, hey, this thing is breaking ground and trying to hover at 1/3 stick, well, you might opt to come in here and drag this 0.5 down to a lower number. I can tell you that I've got a hexacopter that's real powerful for lifting cameras, and it likes to break ground at a 0.35. So I would make that change, and then I would write that to the board. Okay, and then of course there's an expo here if you feel that you need it, and you can experiment with that at your own discretion. Finally, here we have a pitch and roll value. Now, let's say the rates for pitch and roll is about 90%. The expo that's built in is about 65%. If you find, after flying it around for a little bit, you find this is kind of tame, I'm ready for a little more reaction, then you can bring these values up to from 90% up to 200%, which would be 2.0. You may also choose to back off of your expo a little bit. And the whole idea of expo is that around the center of stick, you don't have, it doesn't feel too touchy. It's a little more sluggish at mid-stick. And then when you push the stick over to like full roll or full pitch up, then it starts to react a little more the further you move that stick away from its neutral center position. For instance, if you want to start doing flips with your quad, taking it up to altitude and pulling up a flip, you might want to see this rate up here at about a 1.35, and then your expo drop it from 65% down to 0.3 or 30%. So those are some settings you may wish to change after you get to, get a little bit better flying your quadcopter. Now, personally, I like these settings. I just enjoy flying. I'm not a good multi-rotor pilot at all. Most of my multi-rotor stuff is done FPV, so these softer values, tamer values are good for me. However, I do like a very responsive yaw. Quadcopters don't have a rudder. You're relying on differentiation of thrust to yaw a quadcopter around. So I like to bring up my rate. We have rates over here, and if you trace yaw over past PID, we have a rate value. And you can bring rates up however you want to. And I usually bring my rate up pretty strong there. I don't remember what the value is, but that makes it yaw around a little faster. So that pretty much sums up everything I had to tell you about this, and I hope you have found it informative. If you have, tell your friends, tell everybody. There's just not much more good than I can say. We've got lots of different flight controllers on the market, and they all come at different prices. So many people love the KK 2.0 board. I personally don't care for it. It's a $30 board when you can find it in stock. I'm not big on it. You can get a Flip 1.5 if you solder the pins yourself or solder your servo wires direct onto it. If you don't put it in a case, you're talking about a $15 controller. And even if you buy everything together, what is it, $20, $21? It's the least expensive board I have found on the market, and they always work. And if you follow the guidelines that I've set here in this video and you do things in order, you should have success without any problem at all. And with that, I want to invite you to check us out, our podcast. I am Crash, and I host each and every week the Crashcast podcast. You can find our recordings on iTunes if you search The Crashcast, all one word, or you can download episodes direct from my website at thecrashcast.com. And we are always talking about ReadyToFlyQuads products and our own personal multi-rotor flight endeavors on that show. We even get into some fixed wing now and then. So I invite you to subscribe, like this video, share it with anybody you will, and feel free to leave some comments. If you have any questions, you can also post those as well. But I think I've covered everything pretty well. So with that, get out and build something, fly something, and enjoy this great RC hobby.